Welcome to the world of blockchain where consensus rules supreme. But how is this consensus achieved? Enter voting-based consensus algorithms. These algorithms have been around for decades, tracing their roots to mathematical literature. They're Byzantine fault-tolerant, ensuring their security and stability with robust mathematical proofs. These algorithms are democratic at heart, determining consensus on transactions and pivotal network decisions by tallying up votes cast by nodes in the network. However, it's important to note that pure voting-based systems are rarely used. Why? Because they can be slow and inefficient. To mitigate these issues, most projects employ hybrid systems that combine voting-based consensus with leader-based systems or other mechanisms. So while the democratic spirit of voting remains, it's often complemented by other elements to enhance efficiency and performance. Now that we've touched on what voting-based consensus algorithms are, let's dive into some real-world examples. Picture a network with 1,000 nodes and a decision hanging in the balance. How does the voting process unfold? Well, imagine over 1 million votes being transmitted across the network. Each node might also need to confirm receipt of votes, so that's 1 billion plus messages pinging around the globe. And that's just one round. Each node then reviews all votes to move the decision-making process forward. Upon reaching a decision, new votes are sent out, initiating another round. This cycle repeats, with multiple rounds of billions of messages just to resolve a single yes or no question. But there's a catch. This process doesn't provide a fair chronological order of transactions. Every node proposes an order, adding to the inefficiency. The node that wins the election can place transactions in any order they choose, potentially undermining fairness and introducing problems. That's how a pure voting-based system operates. But what about its application beyond distributed ledgers? While pure voting-based consensus might not be the first choice for distributed ledgers, its influence extends beyond this realm. These algorithms have found their way into databases and other fields, given their democratic nature and mathematical robustness. Imagine a database with multiple nodes, each holding a copy of the data. By using a voting-based consensus algorithm, each node votes on the validity of a new data entry, ensuring data consistency across the network. However, even in this scenario, the limitations of pure voting-based consensus algorithms become apparent. The time and resources required to handle the sheer volume of votes can lead to inefficiency, and the lack of chronological certainty can introduce fairness concerns. Despite these challenges, the principles of voting-based consensus continue to inspire new solutions, driving innovation in fields far beyond distributed ledgers. And that wraps up our exploration of voting-based consensus algorithms. Remember, consensus is the backbone of blockchain, and understanding it is key to unlocking the potential of this revolutionary technology. As blockchain technology continues to evolve, what could the future hold for voting-based consensus algorithms? Let's take a glimpse into the future. Voting-based consensus algorithms have the potential to become more efficient. Today, these algorithms are seen as slow and cumbersome due to the sheer volume of votes that need to be processed. But with advancements in technology and computational power, this might not remain a hurdle in the future. Furthermore, the issue of fairness could also be addressed. As of now, the node that wins an election can place transactions in any order, which can lead to manipulation. However, future algorithms might incorporate mechanisms for ensuring chronological ordering of transactions, making the system fairer and more robust. Beyond distributed ledgers, these algorithms could find applications in other fields. They could be used in systems where decision-making is crucial, like autonomous vehicles or AI-based systems. The future of voting-based consensus algorithms is as wide and varied as the blockchain landscape itself. One thing is certain: their role in decision-making will remain as vital as ever.